Hi, this is Hyunsu or Winfred. Today in this video, I'll be presenting about my side project called EduScript detection via traditional machine learning. A brief introduction, EduScript was basically a collection of Chinese characters that ancient Koreans used to transcribe Korean pronunciations. It was a writing system used during the Three Kingdoms era. In Korea, there are stone monuments called steles. These have inscriptions written in Hanja characters. For steles that belong to the Three Kingdoms era, some contain Edu scripts, especially when the inscriptions contain pure Korean names, political titles, or ranks. There is also Mokgan, which is a wooden tablet that also has inscriptions. Some contain Edu scripts as well. The stone monuments are centuries old, so they have debris on the surface or chasms left by the turbulence of time. So some inscriptions are damaged. But what if, with the power of machine learning, such characters can be recovered? And there might be steles that still remain not discovered, and perhaps this technology might be useful in the future. And of course, it might be a fun idea to apply to elsewhere. I call this EduScript Detection System, or ISDS. I prepared a total of 4,800 in Old Korean words. In the top left corner, which means king, the top right, meaning blue, bottom left meaning garlic, and bottom right meaning morning. Then I pre-processed these images using scikit-learn, the result of which are then fed to train and test sets, equally dividing the number of images to each set. The evaluation of the model was done using SVC classifier, which is powerful for image classification and for small sample size. This is the evaluation report. Now, one thing to note is that the accuracy, which is approximately 96%, does not mean that this model will always be correct when a new test set is used. Misclassification could certainly occur. We see that the first word blue has lower precision than recall, which means that the model may make some mistakes in classifying this word. The third word, garlic, has lower recall than precision, which means that it will be conservative in making predictions. Other words seem fine. This graph basically shows whether each dot, the images, are rightfully located within its plane of prediction. Some dots are in differently colored planes, but I think this might be due to the 2D vectorization process rather than there's something wrong with the image files themselves. This graph basically shows the learning process of the machine or model. The first on the left, the bright pixels are showing positive values and the dark pixels representing negative values. It's basically the machine tracing the shape of each word until it knows which one is which. This process becomes less and less pronounced until it reaches the last image, because at that point, the machine learned all the variances within the images. This graph, I think, it's similar to what I said before about capturing variances by the model. The bar graph seems to decrease in height as principal components increase in number. Confusion matrix shows which word the machine might mistakenly classify. On the right, I was able to find one misclassified word. The picture right shows the word garlic, but the machine classified it as, no, this is blue. So far, we went over how the machine is now able to predict the single words, but what if there is a stele with Hyangchal sentences? That is, the stele contains a bunch of sentences without spaces. That's important because most of steles are like that in Korea. So a lengthy sentence needs to be tokenized, which means it needs to be broken up to pieces. Here I prepared a composite word, a blue garlic, written in Old Korean. Now we need to tokenize it into each block. Since this is image, it contains 4 values for each block: top, left, right, bottom. There's a Python module that helps automatically cut the text area conveniently, but it requires a good GPU as far as I know, and it's called optical something something. I forgot the other 2 words, but I don't have that, so I had to hard code this behavior. So this is the revised methodology. I will still need to train and test the machine or model with the previous data, but give the machine, hey, this is a sentence data, translate what this means. I call this process array tokenization because it requires a vectorization of each block of images into meaningful vector. The rest of the process on the right is the same as before. This is the result. The blue garlic composite word is broken apart by the code, and the machine recognizes the words it previously learned, and then outputs the meaning, the translation. This is another example showing morning king word on the top. The machine correctly recognizes the words. Limitation of this project was the non-use of automatic text area capturing method. Because it's hard-coded, it requires human to cut the text area. I had a small sample size to begin with, but when I get a good computer, I could use a more powerful convolutional neural network to try the same thing here. And of course, I hope there is more stele or mokgan found in Korea and somewhere in Manchuria so that there is a continued research in Old Korean language. Thank you for watching. Bye for now.